Good evening. Welcome you all back this evening. Looking forward to hearing from Morris this evening again on glory of God in the heavens. I thought maybe we would stand and sing one verse of There is Beyond the Azure Blue. Ryan Martin is back. He was gone for a day or two, and he said he would be willing to lead us one verse from his seat. So why don't you all stand? We'll sing that verse, and after that, we'll turn the time over to our brother Morris here.
With his great might, there is a God. In him we live and we survive. From the star God created man. He is our the great I am.
Maybe seated.
Thank you. Good evening. It is a privilege to be with you here this evening again. Through this weekend, we've been enjoying some really down to earth things, eating and drinking, socializing, fellowship, and things like that. I've enjoyed the time here so far, and we're looking forward to just a little more time here than yet part of the day tomorrow with you. Thank you for your warm welcome. So last evening, we looked at some things that were kind of out of reach in more ways than one. So they're so far away and, it's astronomical figures. So in that sense, it's out of reach. In another way, though, is how can I or how can you personally go out and discover the things that we talked about last evening for yourself? Or how can you personally verify that what I said was even beginning to be accurate or even had a semblance of truth? A lot of these things are so far removed from us, and we don't have any kind of really a tangible way of discovering the truth of these things for ourselves because the science of astronomy has advanced so far beyond the level of a normal person. But this evening, I want to change gears just a little bit and bring it to where it's a little more directly accessible to us as normal people. I'm a normal person, so in doing that, I'll be showing some of the things that I've found through astrophotography and things like that. And all of this you could do yourself as well with just a small budget and a little time and a lot of patience and inquisitiveness, a curiosity, and a desire to see more about God's creation. There's a verse that I'd like to start off with this evening that also comes from Psalms, just like we started off last evening, where we looked at a verse that basically was a prophecy. The heavens shall praise thy wonders, O Lord. That prophecy fit with what we had last evening. Tonight we want to look at Psalm 111, verse 2. It says, "The works of the Lord are great, sought out of all them that have pleasure therein." So whatever work the Lord does, it's a great thing. And for those who take pleasure in God and the things he does, when we notice and we're confronted with something that God has done, whether it's in the lives of his people or in the creation he's created, we're fascinated. And we want to learn a little more about it. And we want to try to discover what's God's purpose in this and what's the reason for it. So that's what we'll do some of this evening. We'll take Psalm 111:2 at face value, and we will seek out these things to try to find God's purpose. Sometimes it helps us to actually take a look at the grand scheme of things and step back and look at what's in front of us. So if we were to step outside of our universe and look at the universe, the cosmos as a whole, then what we would see is outer space with lots of galaxies and all the things that are in there. We would not see the earth. The earth would be infinitesimally small. So what we would be confronted with is that God created much more beyond the earth than what he did right here at the earth. So what's the reason God had for this? God does everything for a reason. So what I want to do here is pick up on some things that we left out last evening just to get a sense of continuity here and move on through this. Again, if you weren't here last evening and didn't hear, the R logo in the bottom right corner stands for real. That means you're looking at real pictures, and this is a compilation of about a half a dozen real pictures. Okay, last evening we stopped at the Earth as we were going away from the sun, and now I want to move on to Mars, the next planet out. As we move away from the sun, there's a few interesting facts about Mars here. The surface contains iron oxide. You can personally verify this, like we talked about earlier this evening, by going outside and looking up at Mars. One of the first things you'll notice is that it's not a white star, it's an orange looking star. The reason it looks orange is because you're looking at lots of rust, which is iron oxide, which is what the surface is made of. And of course, some other elements as well. It has a canyon that's 2,500 miles long, 4 miles deep, big enough you could see it from space there, and is 4 times deeper than the Grand Canyon here on the Earth. It has a volcano that's 17 miles high, 370 miles wide. Remember how last evening we talked about how that there's a tremendous amount of variety in the things that God created in the planets, all the geological features. We have the tallest mountain in the solar system here on Mars. We have this huge canyon that's 4 times deeper than the Grand Canyon and could span basically the whole width across the United States. We have a polar ice cap at the top there. Now that's really interesting. It gets cold here in Missouri, and I heard from Dwight that one of the years he was here for Bible school, it got down to -9, which is extremely cold. And we don't get anything like that down in Georgia, but here on Mars, it gets so cold that the atmosphere freezes and falls to the surface. So what you see there at the polar region, northern polar region, is frozen air that fell to the surface of Mars. And of course, it's made of carbon dioxide, so it's dry ice. Now, if we were to look at Mars through a small telescope, we could see something like this, low contrast, just a little surface features, and it would be tiny. But if we have a bigger telescope and we can use something called lucky imaging, it's basically using video photography and put a video camera on the telescope. We could get a video that's typically about a minute to 2 minutes long at a high frame rate of about 100 frames per second. That's fast enough to freeze the wiggling, jiggling motion and the blurring effect that the atmosphere has on this on Mars. And then you can get software and combine all those frames together. And in this case, there was 2,000 frames that were stacked together, and I ran them through the computer, the stacking software, and got this image here, the bigger image. So this is from a 16-inch reflecting telescope, a very doable thing, and we can actually see a lot of what God has done for ourselves. If we have spacecraft orbiting around Mars, we can see things like this. Up in the upper left, there are what's believed to be black sand dunes. And you see them there. Here's other sand dunes, stains on the tops. It's believed that there are jets of gas coming out of those, the tops of those. Here is a whirlwind, the bottom right. And it looks like those whirlwinds actually make paths as they suck up the light colored dust and leave the dark streaks underneath. And we also have what appears to be landslides, or almost similar to avalanches, going down these slopes of the sand dunes. Over here, you see the same thing. So there's lots of interesting variety and features on Mars. Jupiter is the next planet that we come to, and as we look at it through a small telescope, this is about what it looks like, a small sphere with 4 stars moving with it. Those stars that are moving with it aren't actually stars. They're 4 of Jupiter's moons. They're called the Galilean moons because Galileo discovered them in his telescope. And when we look at Mars or Jupiter like this, we can see a couple of cloud bands, not a lot of features, but just a little, just enough to be able to detect it. And you'll see it looks like Jupiter is moving out of the field of view. That's because when we look at the stars with our telescopes, the Earth is turning, and so it's dragging the stuff out there away from us and out of our field of view. So eventually we have to reposition the telescope to get it back in place. So for this reason, tracking motors are nice on a telescope, and they also give you go-to function where you can punch in what you want to see, and the telescope goes to it. and gives you a view like this if you use that same video photography method. Now, if you were to go outside on a really good night, it's very much night specific on how good of a view that you'll get, how sharp a view that you get. But if you go out on a really good night, you could maybe see something about half this good in resolution. But if you put a camera in and you get 1,483 frames in this case and stack all the best of them together, well, in fact, these would be 1,483 of the best frames of probably a group of about 10,000 is what I think I took over a period of about a minute to a minute and a half. So there you can see the great red spot. You can also see one of Jupiter's moons right there to the left. And if you have a spacecraft up at Jupiter, you can see even more detail. So this was taken by one of the spacecraft that went to Jupiter. Jupiter's gravity is 2.4 times stronger than the Earth's gravity, has a rotation speed of 29,000 miles per hour at the equator, has the great red spot, a hurricane-like storm that's been there for as long as astronomers have been looking at Jupiter through telescopes. It's extremely large. You could place 2 Earths across the storm system. So there's lots of extremes around on the other planets. Jupiter has a moon called Io. It's the most volcanically active world in the solar system. It spews lava 250 miles high. You can see one of the active volcanoes right here on this picture. And there's another one right here. There's another one down here. And it's amazing to see how this is working. It is so close to Jupiter that Jupiter's gravitational pull is strong enough that it actually causes ground tides. It's not just that the ocean is rising and falling, but the surface of this moon is rising and falling. This stress cracks open the crust, lava spews out and shoots over 100 miles up into the atmosphere. All this dynamic action and activity is just amazing to see. So Jupiter has extremely powerful gravity, and one of the ways that we can thank God for Jupiter is that Jupiter actually captures renegade objects in the universe that have lost their course, most likely because of the fall, and are on collision courses with other objects and potentially threatening the Earth. But on a fairly regular basis, Jupiter eats up other objects that are on these erratic orbits that could present a danger to the Earth. So God has a purpose for things like Jupiter. Saturn is the next come. Actually, I wasn't planning to show this evening, but since I got onto that, I want to show you this here, just case in point, what Jupiter can do. This was a comet that got too close to Jupiter, and it became mini comets because there was such a strong gravitational pull on the comet as it came toward Jupiter and tried to keep speeding on its own way. But these tidal forces pulled and stretched on the comet until it broke it into 24 pieces. Those orbited around Jupiter, came back, and collided with the planet. And you can see a series of photographs. This is the first one. There's a huge explosion here, hundreds of mile high mushroom cloud, then the scars that were left on the planet's surface after it consumed all those pieces. So again, it's interesting to see these things. Next, we have Saturn. Saturn looks like this through a small telescope. You can actually see the rings. It's one of the most rewarding things to see in a small telescope. On a good night, you can see the Cassini division is sharper, clearer. You can see the difference in tone, color tone in the equatorial versus the polar regions of Saturn. And if you use the photography method I mentioned earlier, you can get a picture like this. This was also taken with a 16-inch telescope. And if you have a spacecraft like Cassini, you can get up close and personal and see it in lots of detail. Saturn has rings that are made of ice particles, and they orbit around the planet at a high rate of speed, but they come back to the same place every time after making 1 year of rotation. And the rings maintain their shape well enough from all those particles keeping their orbit perfectly enough that every 15 years, which is half of its 29.5-year orbit, the rings seem to tilt edge on toward us and they basically disappear from view. That happened just last year. So right now they're at a very oblique angle and we can't see the rings very well. It looks like a line across the face of the planet. Other times they open up more like what you see here. It's a light planet. It actually has an average density that's less than water, and this illustrates that right here. Density is approximately 2/3 that of water. And Saturn's rings, they are Like I mentioned, extremely thin. We'll get a close-up view of some of them here. You can see how they're made up of hundreds of individual ringlets. There's a Cassini division over here, the Encke gap over there. These are caused by small moons that are shepherding the ice particles into and out of certain areas. And we can get a close-up view of how the rings are casting shadows on the part of the planet's surface. Can you imagine how it would look if we would have a ring system like this around the Earth and we could see the rings extending out across the sky, and through the daytime, sunlight would filter through and shadows would cross over the Earth? There are other moons as well that are fascinating, like Saturn's moon Enceladus. It has enormous geysers that eject liquids or gases or ices into space, and there are over 100 geysers that have been found on this moon. Another just exercise of God's creativity and all these things that He's made. This is a planet that the next one we come to, Uranus, it rotates on its side. The blue-green color comes from a methane atmosphere. It has 27 moons and 9 rings. We can't see them on this picture. This is cropped in on just the planet itself. And this one has a moon. I have actually quite a few other moons that I like to look at, but I've blocked them out for this evening. This one shows the jumbled terrain of Miranda, and it has cliff that's estimated to be 3 to 6 miles high. So another extreme geological feature. The next planet that we come to is Neptune, and it's composed mainly of hydrogen and helium, just like the other gas giants, lots of chemicals, just an ocean of chemicals and ices. It has the fastest winds in the solar system, and they move at about the speed of a bullet, like a 22 bullet, up to 2,200 feet per second or 1,500 miles per hour. Actually, a little faster than 22 bullets. So this is a windy place, and you can see the cloud bands whipping around the planet here in this image. It's the stormiest planet in the solar system. There's other things in the solar system. Some of these go farther out than the planets that we just looked at. Comets are an example. Neowise is pictured here. This came through in 2020. Did any of you see Comet Neowise in 2020, 6 years ago? Okay, some of you did. Good. Okay, this is a close-up picture of it from a 10-inch telescope. And that telescope is actually housed in this observatory here in the background. And we were out this evening looking at another comet. I think this was Comet Chuchin-Chan just a year or two ago. And we took my mother out, who actually lives in the house in the very background. And we had a picnic there, and we're watching the comet as the sun sets. Who saw Comet Chuchin-Chan just about a year ago? Anyone know? Okay, a few of you did. Good. So these are interesting objects to see. Here's a close-up view of the nucleus and the tail extending out from it. This is Halley's Comet, and it illustrates how that the orbits of comets have this highly elliptical nature. So they come in from far out in the solar system a lot of times. These periodic comets do. They whip in a tight orbit around the sun, and then they go back into the far reaches of the solar system again. Halley's Comet, we see it only once every 76 years. So we only see it about once a lifetime, if that many times. The last time it came through was in the 80s, 1980s. So it'll be a while until it comes through again. But something happens right here and right over here. We run across the orbit of Halley's Comet. When that happens, we actually run into some of the bits and pieces that came off of the comet that had formed the tail when it was visible, but now are just orbiting around on that same path that you see right here. So when we cross that path, we have a meteor shower. These are called the Eta Aquarid meteors in the springtime and the Orionids in the fall. So when we go through those meteor showers, we're actually seeing parts of Halley's Comet coming into the atmosphere and burning up as a result. These falling stars aren't actual stars that are falling. They're bits of rock and dirt that come into the atmosphere at such a high rate of speed they completely vaporize because of all the friction that's produced from them moving through the air at anywhere from 15,000 to 100,000 miles per hour or more. And if they're big enough, they can totally burn up before they hit the ground, and this is what can happen. This is the Barringer Crater in Arizona. It's about 3/4 mile across from one side to the other. And you can see how that we can thank God for our atmosphere, that gets rid of most of these threats before they ever make it to the ground. There was another event in the Tunguska region of Siberia, Russia in 1908, where there was a giant explosion believed to have been caused by a comet or a meteor that exploded, or an asteroid, probably a comet, that flattened 800 square kilometers of forest, or 2,000 square miles. So God has created lots of amazing and interesting things. And in Isaiah is telling us, have we not known? Have you not known? Have you not heard? Hath it not been told you from the beginning? Have you not understood from the foundations of the world, of the earth? It is he that sitteth upon the circle of the earth, and it tells us how small we are in comparison to him. And it says that he has created these things by the greatness of his might, and for that he is strong in power, not one faileth. And it goes on in the ending saying that he gives power to the faint, and he helps those of us who are weak. Those that wait on the Lord shall renew their strength. At the very bottom, they shall mount up with wings as eagles. They shall run and not be weary. They shall walk and not faint. So as we've gone through the solar system and looked at the way that God has created such an interesting variety of objects, it shows and showcases his creativity, then we have to just wonder what all he has in mind with doing all these things. The first night we looked at stars, and now this evening and some of last evening we looked at planets. The stars are just these hot thermonuclear furnaces. You can't step on a star because it's just a flaming or a extremely hot ball of plasma and hot gases, basically. But these planets are actually areas where we could walk on, we could explore, and maybe it's possible that maybe even God would choose to have some kind of plants and things like that on some of these planets. We don't know. Not on the ones in our solar system. There's no evidence of life whatsoever on any of planets in our solar system. But maybe there's non-sentient life, like what the Bible calls green things in other places. We don't know. But what does he have in mind with doing all these things? There are so many stars out there that it's been said that if we were to try to count to the number of stars in our universe, the estimated number of stars, and if we were to count at 10 billion stars per second, we would have to count for 30 million years before we'd get to that number. Now, that's on the upper limit of stars that are believed to be just within our observable universe. But if we would take the lower number, we would still have to count stars at the rate of 1 billion per second for 30 million years. So that's astounding. But what astronomers have been finding just in the last few years here, after using the Kepler spacecraft to find planets outside of our solar system, they have found so many in star systems near to us outside of our sun system, solar system, that they have now come to the conclusion that there's a general consensus now among astronomers that there are most likely more planets in the universe than there are stars. So more worlds. What does that tell us about our God? The heavens declare the glory of God. We're only seeing through a glass darkly. We're seeing a dim portion of the true nature of God, and we are just kind of left grappling in some cases. But we want to continue on here this evening and look at photos that show us a dim view of the glory of God. And when we're looking through a telescope, we're actually looking through glass or at a mirror. It depends on the configuration of the telescope, whether it's a lens or a mirror, but it's a glass and it's a dim, murky view. But let's enjoy what we see. God used some of the things in the heavens to speak to Job when he asked him the questions that he did. So first, God was demonstrating his superiority over all of mankind to Job, and then he went on and asked him later in Job chapter 38, verse 31, canst thou bind the sweet influences of Pleiades? And this is the star cluster Pleiades. There's lots of beauty here, and it's also called the Seven Sisters. It's often mistaken to be the Little Dipper because of the dipper shape that you can see with these stars here. This is the handle, and this is the bowl of the dipper. It's small enough that you could about blot it out with your thumb at arm's length, but the actual Little Dipper stretches over much more of the sky than that small area. So he asks him, can you bind these sweet influences? Can you bind this cluster? Of course, Job can't do that, but God has done that. And then he asks him in the latter part of the same verse, can you loose the bands of Orion? Here's the constellation Orion, and you can see the bands or his belt there in the center. And that's what you see right there. Job couldn't do that, of course, but God can. We can zoom in on that and see the belt of Orion. And this is what you're looking at when you're looking at Orion's belt, which a lot of you, I'm sure, have noticed. You're looking right through the Horsehead Nebula. And I'll have another picture of that later on. And there's lots of other stars there. But when God created these things, he did it for a purpose. One was so that we would notice them. And he says that in Amos 5:8, seek him that maketh the seven stars and Orion, the Lord is his name. So he wants us to notice those things and then to seek the one who made them. Next, we'll take a look at images that are coming from deep space and galaxies. In particular, by his Spirit, he hath garnished the heavens with these galaxies. So we are in our home galaxy here. When we look out at night, see all those individual stars, we're only looking at our home galaxy called the Milky Way, and we're only looking at a very small segment of that home galaxy when we're looking at individual stars. On this picture, we're looking out through those stars of our own Milky Way galaxy to the other galaxies in the background. And what you're seeing here is called the Leo triplet. It's in the constellation Leo, and it has a couple of spiral galaxies here and the Hamburger galaxy there, which is a spiral galaxy viewed edge on. And here we have a spiral galaxy viewed face on. It's called the Whirlpool galaxy. It's a beautiful galaxy. Most of these pictures were taken with the 10-inch telescope. And here you can see more types of galaxies. This is an irregular galaxy. This is, I think, an elliptical galaxy, a spiral galaxy, and an edge-on spiral. 3 edge-on spiral galaxies here, and a few others, a couple other spirals. This is a star in our own galaxy. We're looking far beyond this star to the galaxy, millions of light years away. And then there's other galaxies. There's the Needle Galaxy, M81, M106, M74, the Phantom Galaxy, and just such a variety. Here's the Deerlick group cluster of galaxies, a big one, some smaller ones through here. Lots of other galaxies around in the background. Stephan's quintuplet over here. You've heard of the James Webb Space Telescope, right? The most recent big telescope they send up, the biggest telescope up there at this point. And it took a picture of this as well, and you could see how it did much better than my telescope with resolving these galaxies. And it looks almost like we can see through these galaxies. It almost gives us X-ray vision because it's using infrared wavelengths to view these galaxies. So infrared radiation can pass through dust easier than optical wavelengths can. Moving on, there's the Sunflower Galaxy in the center. Here's the Sombrero Galaxy, the Whale Galaxy, and others. Here's the Black Eye Galaxy down here. You can see astronomers can be creative with their naming schemes. And moving on, there's M81 and M82, lots of integrated flux nebula all through here. This is dust in our galaxy. We're looking past it to see the galaxies off in the distance. And here's another view of the Whirlpool galaxy. This one was taken by a bigger telescope, the Hubble Space Telescope. And astronomers' attention was drawn toward the very center where it looks like that's the crux of the matter right there in the center. And as they took a highly magnified image of it, they did find a crux right there, Latin word for cross. There is the shape of a cross. Now, why is the shape of a cross there? I don't know. I will say that right up front. But this shape is there for our entire lives. This is not a dynamic and changing shape. It's been there for hundreds and thousands of years by all apparent, by the way it appears. And it looks almost like it could be a cross as viewed from the bottom of a hillside. So I like to think that maybe, just maybe, when mankind rejected the message of God in His Word and instead started looking all over the earth in the biological world to try to invent ways that man could feel like things just made themselves and there was biological evolution and we don't need God, and then started looking in the universe to try to figure out how that all things could have come to existence without the help of a creator, then once again, even though they're looking 30 million light years into space, they can be confronted once again with just another subtle reminder of how we can have a bridge to our creator who made us, who loves us, and gave his life for us. There's the Sombrero Galaxy, a close-up from the Hubble Space Telescope. Another Hubble Space Telescope image here. It's nicknamed the Rose, taken in celebration of the 21st anniversary of the Hubble Space Telescope's commissioning in space. And here is an enormous, supermassive lensing cluster of galaxies. So there are so many galaxies here in this cluster. These are the big fuzzy things, especially here in the center, that some of these other galaxies around here are distorted into the appearance of long, thin strands, like you see here and down here and here, here. Here's a big one. Those galaxies are actually not there along the edges. They are actually here closer toward the center. But these massive galaxies in the center are putting such a massive dent in space-time, similar to how if you'd put a heavy ball on a trampoline, putting a dent there, that light that's coming past the supermassive cluster of galaxies actually turns slightly toward the cluster, and it projects those galaxies off to the side and distorts them. So it's acting kind of like a magnifying glass and a funhouse mirror to show us this view. Jeremiah 32:17 says, Ah, Lord God, behold, thou hast made the heaven and the earth by the great power and stretched out arm, and there's nothing too hard for thee. So if God can make these enormous galaxies, he can take care of all of my little problems as well. Next, we'll take a look at reflection and emission nebulae. So these are clouds of gas and dust in space, primarily gas like hydrogen gas, and then some other gases as well. This is the Lagoon Nebula. Most of these pictures will be taken with the 10-inch telescope, just for reference on what you can see with a common-sized backyard instrument. And this is the constellation Orion. A lot of times people wonder, can you see this color in deep space objects? The short answer is no when you're using a telescope, but if you use photography, you can see this color. So here's the Orion Nebula. It looks like a star in Orion's sword hanging from his belt. If we zoom in on it with the telescope, this is about what we would see through a backyard telescope, a fairly decent sized telescope, maybe 6 to 8 inch. And if we were to take a camera and put it on the telescope, it would allow the light to accumulate because we can leave the shutter open. So it would be similar to us going out at night and looking at the horizon, seeing a barn and a tree and a truck. And each one of those have colors, but we don't notice the colors until the sun comes up and adds more light. Then we can see, oh, there's color there. So what we can do is simulate an exposure. We'll start it now. And you can see as it brightens, there's more color that comes out because it's bright enough when we have photography in astronomy to allow the rods and the cones in our eyes working together to produce a color image, but primarily the cones are what produce the color. So now we have the Orion Nebula, another masterpiece of God's creation, full of color, and this is a true color image. A lot of observatories use monochrome cameras to take pictures of things in space, and they add color later on, but I always use color cameras for deep space objects so that I can capture the true color. This is the Running Man Nebula just above the Orion Nebula. The Orion Nebula is right here. The Running Man is just above it. This is close to the constellation Orion as well. It's the Seagull Nebula. And this next one is in the constellation Orion. It's the Horsehead Nebula. This star here is one of the bright stars of Orion's belt, and the rest of them are up this direction. And you can see the horsehead shape right there. We can zoom in on that for a better view. It's a dark pillar of opaque dust rising up in front of the background hydrogen gas. So there's lots of interesting shapes and features of things to see in the universe around us. The next picture is M78, also in the constellation Orion. Orion is full of deep sky treasures, and it's no wonder that it's actually mentioned in the Bible. And it's one of those things that we can read in the Bible and have a direct visceral attention, a connection to, because we can read it now, close the Bible, step outside and look up and see exactly what we just read about. It's a unique opportunity that we don't have in other areas to get a direct visual representation of what we just read. This is nicknamed the Spider and the Fly, and we'll move on to another one called the Trifid Nebula. This is off close to the region of the center of our galaxy. And the next one is a part of the Rosette Nebula. These are called Bok globules, the dark areas. And we'll zoom through this and go to the next one. This is called the Angel Nebula. Now, I'm giving you the colloquial or the nicknames of these objects. They have complicated catalog numbers. This is the Crescent Nebula right here, but it's much easier to remember the names rather than the numbers. This is the Elephant's Trunk Nebula. This is up in the Milky Way band of light that stretches from one horizon to the other. This is the Iris Nebula. There's lots of dust in this area and a blue star lighting up the central portion of that nebula. This is the Bubble Nebula. So God has some of these stars exploding and making these beautiful um, halos of gas expanding out from them. That's the Tulip Nebula. This is the Spaghetti Nebula, just a small part of it. The Jellyfish Nebula coming up here. These are supernova remnants, so stars that exploded and almost totally blew themselves to bits. This is a verse that says that by his Spirit he hath garnished the heavens and he's made them beautiful. And what we have seen in these last few pictures were the result of destruction. And God brought beauty out of that. So sometimes there are things in our lives that we feel are not beautiful. Maybe it's because of the way he made us, or it's because of some personality trait that we have that we just don't like. Maybe God is using some of that, what we view as a negative thing or destruction, to create beauty in some part of his creation that we have no idea about, we're not aware of. Or maybe it's for us in the future when we'll look back and appreciate it, just like Paul did when he recognized that his thorn in the flesh was for his own good. This is another supernova remnant. So a star exploded and created this beautiful display of gases. All three of those come from the same exploded star. All right, there's another one that's expected to explode soon. We'll just move on from that. There are lots of others here, lots of other nebulas that we could look at. And here, these are planetary nebulae, so they're small. They resemble planets in small telescopes, but they're not actually planets. This is the Helix Nebula. You can easily see the star that was responsible for this nebula. And these pictures, again, were taken with the 10-inch telescope. Now we're switching back to the Hubble Space Telescope. This is the Lagoon Nebula and the Cone Nebula, the Eagle Nebula. They're enormous. This yellow rectangle allows us to zoom in on just a part of this image. The left pillar here is about 4 light years from top to bottom. If we'd put the Earth on here, it would be invisible at the proper scale. The sun itself would be smaller than 1 pixel on the image. So what I'll do is put the whole solar system on here, but we'll have to make it 40 times bigger than normal just to make so that we can see it in a half decent way. And there it is, the yellow circle. That's our solar system times 40 next to this colossal pillar. And this pillar is just a small part of the actual nebula. Like I said earlier, a lot of times these are false color images. I wanted to see what these pillars look like in real color. So I used my color camera at home, took a picture of the central cavernous area of the Eagle Nebula, and this was the actual color that you see there. There is the 4 light year long pillar that we just looked at. So it's amazing to see what God has done. Back to the image that we looked at earlier, and there's another pillar that's about 9.5 light years long, so twice as long as the other one we just looked at. And there's a concave shape pushed out of the top of the pillar there. It's because there's a star just outside the field of view that's giving off lots of radiation and hollowing out the top of that pillar. So there's lots of things happening. These gas and dust clouds, they actually morph over time. They change. They're dynamic. Dust is actually moving around at thousands of miles per hour, and in some rare cases, even millions of miles per hour. But since they're so big and so far away, we don't really detect a change from night to night. Sometimes we detect a change from year to year, but even then it's just subtle. So we keep zooming in on the Carina Nebula here. We can see how this one is enormous. It's actually 10 times bigger than the Eagle Nebula that we just looked at, and got a good idea of the size because of the pillars within it. And here's some other pillars. And you can see shock waves extending out from these jets of hypersonic materials spewing out of the tips of these fingers. So more interesting things that are happening there. Planetary nebulae, close-ups of what we'll see next here. And I'll just move right on through these things. We have the Cat's Eye Nebula, an eye looking right back at us, reminds us that the eyes of the Lord run to and fro throughout the whole earth. We have the Eskimo Nebula, the Ring Nebula, a close-up view of it here again. This is as wide as 1,000 of our solar systems. This is the 8-burst nebula. It's a Hubble view of it, and this is the new James Webb telescope. This also shows that X-ray type vision. It looks almost like we can see through it because we're using infrared wavelengths with that telescope. The Butterfly Nebula is here, and then we have other extreme objects like supernova explosions creating supernova remnants that are that have interesting things going on inside of them. For example, this is one image that is a compilation of lots of different types of telescopes looking at different wavelengths of light. This is an optical image and an ultraviolet, X-ray, infrared, and radio, and we can combine them all together into this one image. And it shows us there's something interesting happening right in the center. That's a pulsar that's spinning, and here you have a close-up view of it. These are stars that almost act like lighthouses. They have two beams of energy that are extending out from them, and if those beams of energy pass over the Earth, then we can hear a blip in our radio telescopes. We can see the signal if we digitize it, or we can hear it if we use the same technology that we use with our cell phones when we talk to other people. We do it with radio waves. So when we point radio telescopes to these pulsars, we can hear, when we tune it to the right frequency, the blip that's coming from them. And I'll let you listen in on one of those stars right now, right here. It's called Pulsar B1933 plus 16. It's spinning, this whole star is spinning at 0.358 hertz. So 1/3 of a rotation per second. Just, you know, or actually three rotations per second nearly. And just compare this to the Earth's rotation period of once every 24 hours. It's much faster. There's another one called the Vela pulsar. You can see it in the background there, or in the foreground, and the supernova remnant in the background. It's spinning at 11 hertz. And I think I may have gotten my tongue twisted up on the other one, on the rate there. But whatever the case, this is much faster. Now the Crab pulsar is spinning at 30 hertz, and you can hear that much faster. When you get up to this speed, it goes from an actual rhythm to a tone. If you take a rhythm and you make it fast enough, you'll have a tone. So it's kind of like stars are out there beating out a rhythm, as well as others that are actually making a tone, like PSR J0437 spinning at 174 times per second. And there you hear the actual signal from that star, that pulsar. And then we have one of the most high-speed rotations of any pulsar known, 642 hertz, and it's just a high-pitched whine. So there are these stars singing all over the universe. And what does a grand symphony sound like? What is it almost like an orchestra out there that is they're all making the music of the spheres in some way that we can't really fathom fully what it's all like. We're going to skip over some of these. We're almost out of time here. There's a black hole, extremely interesting object. So the reason astronomers felt like black holes are probably in existence is because they noticed that there were things that were orbiting, stars that were orbiting around an area of nothingness in the center of our galaxy. And here you can see the orbital motions of those stars plotted, and they are orbiting around what appears to be nothingness. So apparently, what it is there's so much stuff crowded in such a small space that gravity took over and became so powerful that not even light could escape from the black hole, and therefore it went dark. There has to be something extremely massive there anchoring those stars to that orbit. The same thing is happening in the nearby galaxy M87, and there's a jet extending out from that galaxy, and astronomers wanted to see what is causing it. So this is what it looks like in a 10-inch telescope. You can see the jet coming out of the bright center of M87, and with the Hubble Space Telescope, you can get a better view of the jet coming out of that galaxy. Astronomers wanted to see what was in the center of the galaxy, and they suspected that it was a black hole that was channeling matter into these jets as matter spiraled around the black hole and shot off the polar regions. So they linked a bunch of telescopes together across the Earth, and they actually got the first ever direct image of the event horizon of a black hole and the accretion disk. So that was really interesting to see. And there's fascinating things to study about black holes. But some of these things are hard to understand, hard to believe. One of the things that they do is remind us that greater than the greatness of all mysteries of creation is the greatness of God above the mysterious things He's created. We have globular clusters full of stars. Those are other interesting extreme objects to study and look at. You can actually see some of these with binoculars. This is Omega Centauri, and there's almost seems to be no limit to what we can find in the universe around us. Reminds us that the larger the ocean of knowledge, the greater the boundaries of the unknown. The more we know we don't actually know. For 1 Corinthians 13:12 says, "For now we see through a glass darkly, but then face to face. Now I know in part, but then shall I know, even as also I am known." So we have a dim, murky view of just a part of the reflection of the glory of God in the universe around us. We're seeing through a glass darkly. But it says here in 1 Corinthians that one day we will have an exponential increase in knowledge about Him because we'll be with Him. But it won't stop there. Ephesians 2:7 says that in the ages to come, He might show the exceeding riches of His grace and His kindness toward us through Christ Jesus. So we have an eternity of learning to look forward to and of just absorbing the wonderful nature of our great Creator God. And after seeing all the glory that's in this fallen universe around us, it's no wonder that it'll take the ages to come to have all this revealed to us. And we'll continue learning throughout eternity because we'll never come to the end of what there is to learn to know about God because He's an infinite God. Therefore, there will always be more to learn. Just a couple more verses here, and then we'll close. Job 26 says, He stretches out the north over the empty place and hangeth the earth upon nothing. Verse 11, the pillars of heaven tremble and are astonished at His reproof. Verse 13, by His Spirit He hath garnished the heavens. I just picked out a few verses there in that chapter that talk about the ways that God is working in His universe. And then in verse 14, it says, Lo, these are parts of His ways, but how little a portion of Him is heard of Him, but the thunder of His power, who can understand? So it's another way of saying we've only scratched the surface, and we will continue to learn through the ages to come. Feel free to pick up some cards if you haven't already. I think there's probably still some back there. It looks like there are. So help yourself, and thank you for your attention and time here again this evening. And Lord's blessings to you as we prepare for the day of worship tomorrow.
David said thousands of years ago, "When I consider the heavens, the work of thy fingers, the moon and the stars which thou hast ordained, what is man that thou art mindful of him?" And I got my mind with that verse as I tried to comprehend some of these pictures and facts about the stars and the moons. And he says, when I consider the work of thy fingers, to think of God creating these things is makes you feel really small. And yet God is mindful of us for some reason. He has in his greatness, loved man, created man, and cares about man. It's a humbling thought. We thank you all for coming, visitors. Thank you for being here. Just a couple announcements here before we close for the student body, especially in relation to tomorrow. So tomorrow's schedule, it's hanging up, but I'll just mention a few things. Breakfast is from 8 o'clock to 8:30 tomorrow morning. Church service here at 10 o'clock, but some staff pictures before the service at 9:25. So for some of the staff families, try to be here in the chapel before the service at 9:25. And then after the service tomorrow, they're planning to take the big group picture and some individual pictures. So both student and staff, when the service is over, just stay here. We'll remind you of that in the morning, but just letting you know ahead of time. Another thing that will be mentioned again, but just thought it'd be good to say tonight for the students, there'll be interview sign-up sheets being put up for this coming week. We'll give you more detail on that, but you'll be asked to sign up on that interview